Hello, this is Brian Kinghorn, and I'm going to tell you about the multiple end uses feature in MateSel. This is largely about targeting your customer needs as well as your own needs in your breeding nucleus. However, in April 2024, we have extended features in multiple end uses quite considerably, and we're going to cover these extended features in a separate video. So what you're looking at now is an updated video for the standard features of targeting customer needs. And what you'll see is me today with my glasses on, as well as me 3.5 years ago covering the original components. So what are end uses? Well, these are the different eventual uses of your improved genetic material, and key among those is selection back into the nucleus. But for the purposes of this video, it's largely about the trait profiles that you have in the material that you generate out of the current matings. So for example, if you have good genetic variation for resistance to a disease, then you don't want to be sending highly resistant individuals off to disease-free environments. Your customers in disease-free environments have got other trait requirements, and you want to target these for that particular end use, the disease-free end use. Whereas for customers in a disease-liable environment, you want to concentrate your disease resistance for them, as well as other trait components they've got in their objective. Another example might be some customers targeting high marbling beef, whereas others are aiming at production of hamburger mince. You can also consider different roles in industry. So you might have customers who are going to use bulls to cross over Angus versus over Brahman cows, possibly in different regions with different trait profiles required. And of course, the key trait profiles are your elite nucleus versus multiplier dissemination populations, either in your own enterprise or in customer enterprises. All the while you want to be maintaining your nucleus for long-term genetic gains across your customer needs. So that's largely about trait profiles. In the extended video, we will look at extended features. I'm not going to cover those here. You can pause and have a look at those if you want to. But now we're just going to move on and look at trait profiles and managing those in multiple end uses. And here's a nucleus that's producing young stock. And these young stock are either selected back into the nucleus, or they are culled, or indeed they are disseminated to customers. In this example, customer 1 is targeting a market that requires large carcasses, and customer 2 is targeting a market requiring small carcasses. And so there are differences in trait requirements between the customers. And here's an even bigger difference in trait requirements when customer 2 is focusing on the production of young females for sale into the industry. And so customer 2 needs good maternal properties in the bulls that he or she buys, whereas that's not the case for customer 1. So quite a big difference required there. In this simple example, we're just looking at dividing the animals into different categories, whereas the multiple end uses feature does more than that. It looks a generation ahead, essentially. And to illustrate that, I'll use an example from trees. And the different types of trees here are furniture orientated with straight trunks, fast-growing pulp types, and an intermediate type. So we look in the top row here, we've got nucleus-generated candidates. They've come out of the nucleus breeding program, and we want to divide them into 3 categories, that being those that are going to be selected back into the nucleus, typically because they're better genetically, although that might also be because of their attributes to do with genetic diversity. Then we've got those that are going to be used in the furniture industry and those in the pulp industry. So essentially these trees are going to be grown to produce seed for going into those different industries. Of course, it may be if the industry is small enough and the nucleus is big enough, that seed can come out of the nucleus, but in many industries, some kind of multiplier level is required, and that's what's illustrated here. So the furniture industry is made up mostly of straight trunk and intermediate types, whereas the pulp industry is made up mostly of the pulp type and the intermediate type. We want to do a better job of more accurately assembling groups which are destined to be used in the furniture and pulp industry. So what we do is, rather than just make selections, we make selections and matings and generate a new generation where we have a better chance of doing that. So this slide's not directly comparable, but I've laid it out this way for illustration. So if I go back to the previous slide, you can see that we don't have so much specialization in the furniture and pulp industry categories. But if I go to this generation, we see we have done something in the mate selections in order to do a better job. If I jump between the 2 slides, you'll see I've suggested that the nucleus is unaffected in terms of its distribution, and that can largely or even totally be the case when you're using the multiple end uses feature. So to more accurately represent what's going on here, Let's just jump ahead. So this top row is the same as the top row before, and the bottom row is the same as the bottom row in the previous slide, but I've shown the progeny that are generated out of these matings here. So we have the parents, which are the nucleus-generated candidates that have been selected and mated, their progeny, and then we have the sorted progeny. And there are two ways that we're making progress here. One is by having a set of progeny which are better set up for you to make the division into these categories. And of course, the second part is the dividing of those progeny into these different categories for the pulp, furniture, and nucleus components. So just to summarize that, at the stage that we're making selection and mating decisions, we accommodate not only targeting a good nucleus population, that we also look for dissemination. An important point to note here is that in setting up these specialized matings for pulp and furniture industries, you are not pre-deciding the fate of the progeny that come out of these matings. What you're really doing here is setting up the outcome so that you have more opportunity in the future to make the split between these three different end uses down here. For example, a mating that comes out of this furniture matings may produce progeny that once they're evaluated and their EBVs are seen, they may warrant inclusion in the nucleus. So you are not pre-deciding the fate of those matings. A simple way of looking at multiple end uses is to consider genetic merit of the candidates on a single scale. There's a truncation, which of course in real life would be optimal contributions, but just for representation, some individuals are culled. The head of the breeding program is targeted very much at your nucleus gains. With the tail of the breeding program, we take the opportunity to diversify the matings and selections in such a way that we have a better opportunity to satisfy customer needs. And yet, of course, matings made at this end of the distribution may well end up providing progeny that are used for selection into the nucleus. So let's look at how we implement multiple end uses in MateSel. If you've been using it already, you'll have switched it on with a switch of 1 in MateSel.ini in this place here. And you can still do that. If you put a 1 there, it will look for the old style parameter file. Here it is here, the old format, and it will give you a run. So let's look at that here. This is the old EndUses.txt. You'll get a result. We've changed the way we scale things, so you will probably have to reduce these weightings on end uses other than 1 to get a similar result. Otherwise, it is supported. However, you get much more functionality with the new format. What you do for that is put in the number of end uses that you want. And with EndUses.txt, the parameter file missing from the project folder, MateSel will create that for you. So I'll save MateSel.ini. There's a blank EndUses.txt. Here's a job where I've already opened the data file. And when I click Run, MateSel reports that it has written an EndUses.txt for you. So that's a template. Let's look at it now. Here it is, and it's customized to your exact traits and markers. And the other big benefit of going in this direction is that when you make changes to this file during a run and then click Update, it will take those changes on the fly. So recommended to go for the new format, even although there's a lot extra stuff in there. That'll be covered largely in the extra video, which we have for extended functions. Before moving on to some demonstration runs, let's look at EndUses.txt. So you have the number of end uses that you want and the number of matings you want within each end use. And this acts as a proportionality in case the total number of matings that you have to have according to grouping or what's in MateSel.ini is different to the sum of this. But generally, it's the number of matings you're looking for. So the next section is looking at the trait profiles that you're targeting across their different end uses. We do have index as if it were a trait, so that for end use 1 here, it's purely going for the index as in the data file. Whereas end uses 2 and 3 in this example are targeting wool and meat, with wool traits getting higher index weights for the wool index and meat traits getting higher index weights for yearling weight and carcass weight. So all these indices are internally scaled 0 to 1. That's within each end use. So that the worst to the best animal is scaled EBVs 0 to 1. And that makes it more easy for them to be set up to compete with each other in the process. The next component is the weightings for markers. In this example, we're pushing upwards for the allele 1, favorable probably allele of marker 1. And here we're looking to strongly avoid possibly a genetic defect. That's the 2,2 genotype of marker 2. Now these weightings are not scaled, so that a -10 is 10 times more powerful than a -1. Whereas up here, if we multiplied all these weightings here, for example, by 10, it would make no difference because it's the relativity within EndUse for traits. So that when it comes to pushing traits higher or lower for genetic merit, this is where we do it. So we're pushing the EndUse one, probably the nucleus, harder than the other two EndUses. And this is where you ensure that your nucleus has got priority if that's what you want. Almost invariably, that will be what you want. Here we're going for extra avoidance of progeny inbreeding, -1 here. We'll have a demonstration of that. And here's where you declare the importance for diversity management for your different EndUses. And so here we're declaring that the progeny of EndUse 2 matings have got some chance of getting back into the nucleus, and therefore we want to pay some attention to the coancestry of those in the overall population. Whereas EndUse 3, we're suggesting they're not important for coancestry, that's purely for terminal use. However, it may be that even although they're not coming back to the nucleus, we want to have some diversity in that EndUse, and we'll talk about that at a later stage. Now this is largely related to the extended features, which we get in a separate video. Here you can declare that EndUse, in this case EndUse 1 and 2, belong to the same population, population 1, whereas EndUse 3 is a separate population. So this might actually be the beginning of a new line, or it might even be that you want to have diversity in a terminal EndUse, even though it's not coming back to the nucleus. And so for population 2, you ask for some diversity. And that's the example here. Please give us some diversity management in population 2, even though it's not going to come back to the nucleus. And it's treated separately from the main population because that diversity that we seek for dissemination doesn't have to relate to the overall population. It's diversity for the sake of diversity because you don't want to put all your eggs in one basket for your disseminated material. So these last few lines of EndUses.txt contain a range of parameters to do with management of coancestry within and between populations, and that turns out to give you quite a bit of power in a range of different functions that we'll cover in a separate video. What I'd like to do now is give you an introduction to implementation. Here is the file I've just opened. If we go to run it, it will tell us that it's made EndUses.txt, so this makes it rather easy for you to get started. There's the file that's just been created, and we'll make a few edits to that. First of all, the numbers of matings I'll set to 20 for EndUse 1, 15 for EndUse 2, and 15 for EndUse 3. And you don't have to adhere exactly to the formats of the numbers, as you can see there. Now EndUse 1, which is in this column, is going purely for the index. Let's send EndUse 2 chasing after birth weight only, and EndUse 3, let's send that after yearling weight only. And that makes for simple illustration when we come to look at the results. So these are the weightings for markers, which we'll handle later on. And you can see that by default, the weighting on EndUse 1 is 100%, with reduced weighting on the other EndUses, and we'll stick to that. And you'll notice down here that the weighting on coancestry is only on EndUse 1, so at this stage we're not interested in diversity management in EndUse 2 and EndUse 3. So let's save that and go ahead with our run. I just need to click run again, and I'll come back to you when that has evolved. So that's the job well converged. There are a couple of points I've got to make to you about the frontier before we look at results. You'll probably need to set the number of generations for frontier building to be quite high because MateSel's got the extra work of allocating matings into EndUses, and that takes more time to converge. The other point is that the scale for progeny index is now quite different. It goes on a scale from 0 to 1 for the EndUse indices. And of course, if we selected on average, we would get somewhere around a half, and that's where this scale is starting. And the maximum is somewhere below 1, because 1 is the maximum index value for any one EndUse. Now we can look at the mate selections. We can see that if I sort on EndUse, which I've done here, Wayne is the only sire that is used for EndUse 1, and that's because he's the sire with the highest index. Connor is the only sire that's used for EndUse 2 because he's the sire with the highest EBV for the first trait, and that's what we asked for birth weight to be maximized for EndUse 2. For EndUse 3, we were going for the second trait, yearling weight, and London is the highest for that. And of course we can see that also in the sire used here, 20, 15, 15 for these three sires. Now let's see what happens if we go for 25 degrees. And that's well converged. Now we can see for end use 1, we've got some variation in use. It's not just Wayne. Magnus and a few others are coming in there. We're still going quite aggressively for genetic gain, so Wayne is still dominant. However, we have not asked for any diversity in end use 2 and end use 3, and that's exactly what we've got, with Connor and London still being the sole sires used in those two end uses. And as you see, when I move over to 45 degrees, I still get the same. Connor and London only being used in end uses 2 and 3, but now more diversity within end use 1 in order to cater for what's being desired. So let's look at getting a little bit of variation into end use 2. We'll put a 75% weighting on coancestry in that end use. What's going to happen here is that the frontier is being pushed out from where it was. That's because we've got more coancestry available because we're bringing in another end use. So the frontier is not appropriate to the new conditions. And if you want to have a frontier that is appropriate to your current conditions, then just click stop and run, and that will happen. So let's now print matings. And we can see that for end use 2, there's quite a bit of variation. Connor is still reasonably dominant, but there's been quite a number of other sires brought in. Whereas for end use 3, where we didn't ask for any diversity. Now the issue of course here is that the progeny from matings in end use 2 could end up being selected back into the nucleus, so the diversity you're looking for in end use 2 is related to the nucleus. However, if you wanted to have diversity in end use 2 not related to the nucleus, just diversity for the sake of having not all your eggs in one basket, that's something that we cover in the extended video. So I've redone this run at 0 degrees so we can have a look at the trait profiles that come out. So the run has got no weighting on coancestry for end use 2 and 3, and we're at 0 degrees. What we can do is print matings. We've seen those before, but now we can look in the file out enduses.txt, which is written every time you click print matings. And we can see that the index is high for end use 1 as we asked for, and that's the highest possible for 20 matings. For end use 2, we asked for trait 2 to be high, and you can see that 1.35 beats the other two end uses quite nicely. And for end use 3, we wanted high for yearling weight, and that's also been achieved quite well. Let's go and see what happens when we go to 25 degrees, and I'm using soft constraint on target degrees because that works quite well with multiple end uses we find. And we can click print matings and go and see what's happened in the output file. So we can see that the advantage in index has gone down, but that's because we're seeking more coancestry in end use 1, and that's an inevitable outcome. But the end use 2 and end use 3 are pretty good still. They will change a bit because there will be some change in the dam selection side in order to get the best coancestry females onto end use 1. So let's go to 45 degrees. And when we print matings and have a look, we can see more reduction in value for the index. Now it can come to be that the end use 2 and 3 would actually have better index values, but that's not going to happen likely in this situation because we're still pushing for trait 2 and trait 3. So it's going to be easier for us to make a comparison here by going for index for all 3 end uses. So let me save that and update. Now the frontier is not appropriate to the solution, so if we wanted to get an appropriate frontier we could click stop and run, but let's just let this converge on the current frontier. Okay, let's print matings and go to out enduses.txt, and we can see that already end use 2 and end use 3 are getting just about as good stock as we are in the nucleus, and we can even show that more strongly. I can do that by going to a higher constraint in coancestry and let that evolve. So I pushed that down to 0.05 and it's pretty well converged, recalling that the frontier is not appropriate, so we don't necessarily expect to get right there. So if we click print matings and come, we can see that the index is actually way behind for end use 1, even although that's the nucleus that's got the high priority, and that's because we're going so strongly on diversity that it's releasing good resources genetically for index to be used in the customer end use 2 and end use 3. So let's look at manipulating genetic marker outcomes within the specific end uses. When we look at the marker management tab, and this is true also of the trait management tab, these results are accumulated over the different end uses, so we don't see anything specifically there, possibly by modality or so, depending on what you're doing. The key place to go to is the file out_enduses.txt, which gets written every time you click print matings or indeed stop the run. So let's look at marker 1, genotype 22, which we consider, let's say, to be unfavorable for end use 1, and yet we've got a 25% frequency of that genotype in progeny in that end use. So let's say we want to get rid of that totally. And for marker 2, allele 1, let's say that's the favorable allele, that's sitting at 58% in end use 3. Let's say we want to increase that in end use 3. So what we do is we go to EndUses.txt, we'll put a strong weighting against the 22 genotype in that end use to discourage that happening in end use 1, and we'll put a positive weighting on the allele frequency for marker 2 in end use 3. So we save that and click update, and that's the beauty of the new version of EndUses.txt working with MateSel. As you make manipulations in the input file, you can update them. So already that's come to a conclusion. We click print matings and looking out EndUses.txt. So just to remind you, we're trying to reduce this 0.25, we're trying to increase this 0.58. And there we go, we've got rid of all heterozygous matings for marker 1 in end use 1. And we've increased the frequency of marker 2, a favorable allele in end use 3. So these are quite arbitrary examples that I've given you, but you can see you can make manipulations and get results quite quickly without redoing the run. And of course, what you can do if you're not happy with these results on this page is you go back to your EndUses.txt file, make the manipulations, and then update over here in MateSel. And that means that you can discover what weightings are going to give you the sorts of outcomes you want, not just for genetic markers, but also for progeny inbreeding, for example. Which leads us on to looking at progeny inbreeding. So for the standard run, we've got values of around about 4%. So let's go to EndUses.txt and say that we want to reduce progeny inbreeding in the first end use. We'll give that a moderate weighting, save that, and update. So we print matings, look at our result file, and if we update it, we've got similar results for end use 2 and 3, but a much reduced progeny inbreeding in end use 1. Now just to illustrate, let's say that we were wanting to push it upwards. So this is just an illustration, although there may be some reason in some end uses you might want for experimental design reasons to have high inbreeding. So we'll save that and update. There we are, and print matings and look at our result file. So if we look at these three values, this has gone up considerably to over 10%, and end uses 2 and 3 have been maintained more or less the same. It's more difficult to shift those two because Connor and Landon are really quite well entrenched in these end uses, and with limited selection on the female side, it's difficult to make manipulations on progeny inbreeding for that particular case. So now we'll go on and look at a small example from the published study. And this uses the same examples we've had in the slide with 3 end uses: the nucleus, terminal customers, and maternal customers. And the study is here. I'm going to treat this graphic quickly, but you can pause and look at it again to get more understanding perhaps. So we've got the nucleus index, the terminal index, and the maternal index here. And within each of those, we've got the groups of animals. The nucleus animals, these are uncompromised by selecting with high priority into the nucleus. Without multiple end uses, the results are in this red bar. With multiple end uses, we have the terminal in green and magenta for the maternal results. So if we look at the terminal index, the individuals that are sent to terminal customers with no multiple end uses are here on the red bar. And if we use multiple end uses, the animals that go to the terminal customers are this much better. Likewise, if we look at the maternal index, this is the value here of those that would be sent under no multiple end uses. And with multiple end uses, we have distributed the mating such we've got better opportunity. Now, these results depend on how good a job you do at making the selections into the different groupings, and that's described in the paper, but I think you can see there's some considerable benefit to be had by setting up the matings a generation before in order to get this result. Now we'll look at a case where we can use multiple end uses for the same objective without different traits. And this example is inspired by a slide from the committed matings video. So if we need to use eggs from these salmon or prawns from all females to satisfy dissemination and sales, or maybe a certain proportion of these females, higher than we need for the nucleus, then we can use two end uses, nucleus and dissemination. And the text file might look something like this. And you'll see that both of these end uses are heading for the normal index, and that we're looking for 23 matings to go into the nucleus, 77 for dissemination, and anything that's left over would be culled, and that could be 0 in terms of numbers, with priority given to the nucleus. Now, if you had a total of 100 matings, then you might be as well just to do a simple MateSel run and select just the 23 best matings and use all the remainder for dissemination. However, with this setup, what you can do, of course, is change the character of the disseminated individuals by having a separate set of index weightings for them. Moving on, let's look at other applications. Simultaneously target different pathways in dairy. So you could be looking at for elite matings and commercial matings. And in the commercial matings, you would not have an interest in diversity to the same extent, or for different reasons perhaps. And that might be challenging in MateSel because there's so many commercial matings. However, there's a trick to handling that, which I'll show you quickly here. And that is that we can consider that animals that are generated by the nucleus that can be disseminated might be used in commercial farms that have got different end uses, such as crossbreeding, tick resistance, etc. What we can do is simply enter these in the data file as females requiring a very large number of matings. So farm 1 requires 500 matings, and it's a single female as far as MateSel is concerned, and likewise for the other farms. Then when we do the MateSel run, we can have dissemination across all those different commercial entities, balanced with decisions about use in the nucleus. So the two purposes for showing in this slide, one is to show that there is a different way of doing things if this is what your scenario looks like, and the other is that for situations such as we're discussing here with very large number of matings, you can group matings according to farm or region or whatever, and you can read about this under tips and tricks in the manual. Another use for multiple end uses is as a prelude to splitting breeding lines. And this graph tells you something a little bit about that from the video Managing Trait Distributions, Should I Manage My Traits? And so it is possible that you might start to use multiple end uses so that you're in a better position after a number of years or generations to make the hard decision to split your breeding line into 2 or more directions. Another application is to make resources for specific research, such as generating high and low selection groups, or maybe you want to do a particular test as to how well certain animals or certain categories of EBV perform in certain aspects of your operation. And lastly, we'll look at grouping and tricks. The thing here is that you can use both grouping and multiple end uses simultaneously. These are both ways of categorizing animals, but the key difference is that for grouping, you do the categorization and you include that information in the data file. Whereas with multiple end uses, MateSel does the categorization and you don't have to include any information in the data file. However, these two things are disjointed. For example, you cannot specify that end use 2 matings must come from group 2 males mated to group 3 females. You can't specify that, but you can push for it. So what you do in this example would be to make an extra column with only group 2 males, or possibly a subset of group 2 males having a positive value in there, and the same for group 3 females. So then for that trait, which is a dummy trait you've entered into the data file, you put a big weight on that trait for end use number 2. That way, end use 2 will attract group 2 males mated to group 3 females. Another thing you can do is to consider use of non-trait traits such as age and location. So for example, you might want to make certain types of matings with certain trait profiles, but only that they come from certain age animals, like older rams with younger ewes or vice versa, and that you only want them to be taking place at some location that you've got within the operation that is being run by MateSel for this run. I'll end with a comment on convergence, which can be slower under multiple end uses. We're not just selecting individuals into different end uses, we're mating like with like in order to give concentration of trait profiles into these different end uses. And that means that multiple end uses depends heavily on mate allocations, and that's more computationally demanding. So when you're using multiple end uses, pay particular attention to convergence and make sure that your job is well conversed before you accept the results. Well, that's the end of this video. Thank you for listening.